There are no affordable ways of removing fluoride from water while allowing all the other ions that, like salt and minerals that we do need in our body to pass through.
And by salt, do you mean any dissolved mineral rather than just table salt?
Exactly, any dissolved mineral. The only way we can remove fluoride effectively is to remove all salt from water using the same technology that is used for seawater desalination. But that is really expensive. It can be quite energy intensive.
What makes ions difficult to separate from each other?
They are so small. And, separating ions with different charge is doable. But differentiating ions that have the same charge from each other, they are all so small and so similar in size. It is very hard to use a filter to separate them. Making the pores so tiny is difficult, and their sizes are not that different from each other. So even then, you don't get much differentiation.
How does your filter work?
The inspiration for that comes from biology, actually. If you look at our cell membrane, there are ion channels that will pass one ion but not the other. And it is this tiny, tiny, tiny pore, only slightly bigger than the ion itself. So two of them cannot squeeze side by side. The size for that is under 1 nanometer. That is really tiny.
But that is tiny. So these pores are like the holes in a sieve.
You can imagine it like that, except what we did was take this pore that is already so tiny and have functional groups around it, chemical structures around it, that will interact with one ion more than the other. It is not only a tiny pore, but it has groups around it that will attract one ion more than the other or bind one ion more than the other.
So these are like little bouncers on the door, letting some in and some out and not others.
Yes, exactly.
How do you do that?
So making the tiny pores with bouncers on it is really, really hard for us humans to do using synthetic chemistry. You cannot drill a 1 nanometer pore with anything, to be honest, let alone stick functional groups on it. So what we did was to use chemistry, polymer chemistry. So polymers, as you may have heard, are long chain molecules. It is sort of like if you imagine a big necklace, it is a long chain of repeat units. What we did was to make long chain of 2 different kinds of beads, I guess. Some are very hydrophobic, so they are sort of like Teflon. Some are extremely hydrophilic. They are called zwitterionic.
What does zwitterion mean?
A zwitterion is a little molecule that has a plus charge and a minus charge next to each other. And because of this, they have had this ability to sort of zip up together because pluses attract minuses, and they will zip up into these sort of channel-like structures. So the first version of this idea led to about 1.5 nanometer channels. But our goal was to shrink those pores so we can separate ions.
So 1.5 nanometers is still too big.
Yes! So my student, Sam Launder, he came up with this idea that if you can cross-link this polymer, like make extra bonds after you make the nanochannels, make extra bonds that hold it even tighter, we can bring the pore size down to what we really wanted to reach. And he made it work beautifully.
It reminds me almost like of those face masks you say that tighten your skin and you feel it tightening and pulling on your skin together.
Absolutely, absolutely.
So you apply this cross-linking and everything just sucks in together and makes it all shrink down.
Yeah, or if you wash your synthetic clothes in hot water, then you can see all of that weave gets tighter.
And I imagine too, if you wanted to separate out things other than fluoride and chloride, you've just got to tweak which of the 2 chemicals you mix together.
Exactly. So that is our next step. We want to see how many different things we can achieve, right? There are certain challenges out there that don't have any membrane, any filter that addresses it, that have no affordable technologies to solve these problems. There is some research in lithium recovery from drainage from landfills so that you can recover this lithium and make more batteries from it. There are so many things we can do, it is even hard to choose.